Everyone, it's my first video of the year for you. I'm obviously not there. I got to take care of my kids with doctor-related things, and so can't be there. But I do wish you a happy long weekend. And if you're working hard, you also got to play hard. Play very hard. It is a long weekend, but please don't play so hard that you don't get any work done. That's just counterproductive. Okay, you got to balance it out and enjoy both sides of the world. Now, today, the goal is this. I'm going to assume people are fairly comfortable with factoring, the mechanics of. So I want to try to expose you to as many quote unquote, straightforward word problems involving factoring. So I have one question that has to do with rectangles and geometry, and that's right in front of you on your sheet. I'm going to skip number 2. The goal was that everyone gets into groups and you try to help each other solve these questions on a whiteboard or a paper strip on the walls. But since I'm not there with you, I decided to scrap that and I'll just work through it with you instead. Okay. Question 2 is a kind of a puzzle. I'll help you with that. And we're just going to skip number 3. All right. My goal is that you see the connections between these questions and factoring. Even if you might not have seen these questions before, everything here has to do with expanding and factoring. So let's see what you can do. The answer key is already provided for you. There are plenty of questions that you can try. I am also leaving with the substitute teacher a chapter self-test that is essentially stapled onto the sheet. The answer key to that is also on the back side. I blew it up so that's easy to read. I hope that will be of use to you. If you didn't know, come next week, there is an evaluation looming ahead. Okay, so please study hard. The 2 questions I'm going to do is question 1 and 2. So let's do it. Here's an example of how factoring can play a role in geometry, specifically with rectangles. A rectangle has an area of 6x squared minus 24. Would you please change your 48 to a 24? Determine the expression for the dimensions of the rectangle. What do I mean by dimensions of a rectangle? Long story short, there are only 2 dimensions we need to worry about, and that means it's going to be length times width. How is that related to the question? Oh, the question has graciously given me an area. And you know what the area of a rectangle is. It is length times width. So literally, area is 6x squared minus 24, but it is also length times width. I hope you see where I'm going. This is a binomial. It is a polynomial just straight up. It's in standard form. Whereas here, I have 2 different variables or 2 different things multiplying each other. You don't have a multiplication here, but with your factoring practice, you might recall, oh, I think I could figure out how to turn it into a multiplication of 2 things. Okay, so I have not mentioned the word factoring anywhere here, but through your practice, you need to make that judgment call and say, that's probably an effective way to turn something into a multiplication of 2 things. So here, watch this. I'm going to factor a 6, leaving me with x squared minus a 4. Okay, you can say that is 2. You could technically say this is length and that is width, but that is very primitive, and it's not the case considering how we have an x squared here and a nothing there. There's a reason behind what I'm saying, but just believe me for now. Okay, instead, I'm going to identify this. Thanks to my lesson 2.5, this is a difference of squares. And if you remember, something squared minus something squared can be written as 2 binomials where it's a, b, plus, and minus. That was a pattern that we saw. So x squared minus 4 is like x squared minus 2 squared. So what does that turn into? X 2 x 2 plus minus. This is going to turn into x plus 2 and x minus 2. That's it. So determine the expression for the dimensions. I'm just going to arbitrarily say that 6 goes with one of the x's, the x minus 2 goes by itself. We'll say the length could be 6x plus 2, and the width could be x minus 2, length and width. How many possible dimensions are there? Well, this is the only expression that's possible, but we don't know what x is. Long story short, there's a million different dimensions that's possible as long as we had given it another x value. Like if I said x equals 0, then if x equals 0, then my length would be 0 plus 2 times 6, and 0 minus 2 minus 2. Width can't be a negative value, so let's try a much larger value. Let's try like 10. If x equals 10, length would be 10 plus 2 times 6. That's a 72. Take my word for it. Width is 10 minus 2. That's an 8. But if x could be something else, my length and my width would change. And so the answer to this would be unlimited. As long as x values are different, then we can have different dimensions. Okay? Oops. I should probably keep those there. Let's move on. Here's a thinking question, and I'm wondering how many people will be able to work on this. Oh, something I didn't mention. If this is going a little fast, as you see, there is a video, and so I'm going to put the link to this video on our Brightspace. So if we're moving a little fast or you're not having time to copy this, you have no idea where we're going, blah, 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 you're free to watch this again by going to our Brightspace. Okay. Number 2 is a puzzle question. Is there a set of consecutive integers b and c, as well as consecutive integers m and n, such that the equation below is true? By consecutive, it means it's right next to each other. So if that's like a 2, this could be like a 1. Or maybe that could be a 3. Either way, these numbers are consecutive. So here are some mystery numbers. What the heck am I supposed to do? Nothing really. You're essentially supposed to guess. But that's really hard to guess random numbers out of nowhere. So instead, I'm going to try to make things a little bit easier by multiplying this. Multiplying these binomials gets me x squared, n times x, m times x, and m times n. Woohoo! So here it is. I need two numbers that will multiply and get me a c. The same two numbers will add and get me b. And yes, it would be nice if this was consecutive. So from there, this is our clue. We're going to test it. Where did I get this information? Well, isn't that how we expanded and factored? So the relationship between the standard form and this factored form is two numbers that multiply to get you a c, and the two numbers will add to get you a b. So, okay. How about we practice it? We just test it out. What if m was 1 and n was 2? What is 1 times 2? It becomes a 2. What is 1 plus 2? It becomes a 3. Wait, did we find it? Is m and n consecutive? Yeah, 1 and 2. What about b and c? That would be a b and that's a c. Are they consecutive? Oh, yeah, they are. Maybe we found it. Here's another one. What if maybe I should leave all that there. Sorry about that. What if m was a 2 and n was a 3. So m times n. M times n is 2 times 3, which is 6. What is m plus n? That would be 2 plus 3, which is a 5. Oh, m and n are consecutive. B and C are consecutive. I think we found another one. So T questions typically, they're sometimes, especially if it's asked this way, right? Is there a set of consecutive digits? It doesn't say find one. They're asking, is there one? Is there more than one? I don't know. So as long as you give me one of them, you will get your full marks. But now that you see the answer, I hope you understand. There wasn't any special mathematical tool that you had to know to solve this. All you really needed to know was to be able to connect expanding with factoring. And the rest is just sort of playing around with numbers. All right. So skipping number 3. On the back side, there are questions very similar. I wrote the symbol beside each question based on what kind of thinking or what kind of approach you might want to take. Application questions, it's harder because it's in words, but it's still a very straightforward factoring and expanding. Number 4 and 5 are a little bit more trickier because you have to sort of talk about it, try things, experiment, and find your way out of a puzzle. Okay? But I really hope you will find success with the answer key here. Please try as much other practice as possible, and I expect you to suffer well, play hard, work hard, and come back Monday refreshed for a test review. Okay? Have a great weekend, and we'll see you when we get back.